Still talking about complex geometry, we now look at distance and midpoint in complex plane. Distance and midpoint in complex plane. Like I said, this bears a lot of resemblance with what we considered in the coordinate geometry playlist. In case you want to check that out, you can just go to my channel, go to my YouTube channel like this, and you'll find, go to playlist, right? And from playlist, you look for coordinate geometry. Yeah, this right here. So you have, different areas like that. So that clears up whatever might be confusing about whatever we are doing with complex numbers. Okay. So back to the deal. So a complex number is written as z equals x plus yi, or if you like, x plus iy. It corresponds to the point xy in the plane, where x is the real part, that's the horizontal axis, and y is the imaginary part, which is the vertical axis. So if I say z1, I mean x1 plus y1i, which can also be written in coordinate form, like x1 comma y1. X1 is real, y1 is imaginary on the Argand diagram, right? Then x2, I mean z2 is x2 plus y2i, which implies x2 y2. So talking about the Argand diagram, we mean something like the Cartesian coordinate, but not quite, right? But exactly the same concept. So imagine you have this and this. So imagine you need to represent 3 plus 4i. Sometimes it's also written as 3 plus 4j. For electrical people, means current, so they can use j. So in this case, you have your x, right? So this is x plus yj, x plus yi. So that means in on the x pattern, you have one, two, three. This is, so you mark your three here. This is three. And for the y, that's for one, two, three, four. You can mark your four here. So where they meet, this is the point now. So this is the point on the complex plane. This is 3 plus 4i, or 3 plus 4j. So if you join this up, now that's the distance from the origin. And of course, this angle here is the argument, angle theta, which the uh line of the complex number, the which the line which the complex number point makes with the origin, like that. Okay. So this is not a Cartesian coordinate, now it's complex plane. But it's the idea is looking like the same kind of thing. So now we talk about distance between two complex numbers. So it also bears close resemblance with what we have in Cartesian coordinate system. So the distance between Z1 and Z2 is usually Z1 minus Z2, which is equal to square root, absolute value of Z1 minus Z2, which is square root of X1 minus X2 squared plus Y1 minus Y2 squared. This is the same as the Euclidean distance formula. So how do we arrive at this, right? You may be wondering. So, okay, I think I had left something. Okay. So how exactly do we arrive at this? Okay. So to arrive at that idea is this. You have the absolute value of Z1 minus Z2. Absolute value of that. So we know Z1 is X plus X1 plus IY1, if you like, minus Z2, that's X2, right? Minus IY2. X2 minus I y2, like this, absolute value of this. Then we have square root of x1 plus I y1 minus x2 plus I y2, like that. So we then collect like terms, and like term here talks about real parts. So x1 and x2 are real. So we have x1 minus x2. Oh, what am I doing? No need for the square root yet. That's it. It's still absolute value, sorry. So absolute value is now x1 minus x2 plus, for the imaginary part, we have I into y1 minus y2, like that. So, and the general idea for this is that this is square root of x1 minus x2 squared plus y1 minus y2 squared. That's like the modulus of that complex number. So, and that's exactly why the distance between Z1 and Z2 is given as this. So this it is more like what we also have in coordinate geometry system. So it's a kind of coincidence that is so beautiful. So find the distance between Z1 equals 3 plus 4i, Z2 is 1 plus I. So the step one is subtract. So Z1 minus Z2, you have 3 minus 1. That's then for the real part, 3 minus 1. For the imaginary part, 4 minus 1. So you have 2 plus 3i. So if you take the modulus, you have absolute value of 2 plus 3i, which is square root of 2 squared plus 3 squared, which is square root of 13. And the answer is root 13 in that case. So, of course, root 13 is 3.60, all this that you have here. So here to write the code, Python code, you have Z1 is 3 plus 4j, Z2 is 1 plus I 1j. So distance is absolute value of Z1 minus Z2, and then you get the distance to be 3.60 with that square root of 13. Then, for example, 2, you want to find the distance between Z1 is minus 2 plus 5i, Z2 is 4 minus I. So the solution, you have Z1 minus Z2, and that is equal to minus 2 minus 4 plus 5 plus 1i equals minus 6 plus 6i. So absolute value of Z1 minus Z2 is then minus 2 minus 4, that's minus 6 squared. Like that's minus 6 squared plus 6 squared. That's square root of 36 plus 36, which is square root of 72. That is 6 root 2. And the answer is 6 root 2 for that distance between Z1 minus Z2. Then we talk about midpoint of two complex numbers. The midpoint is given by Zm, which is Z1 plus Z2 over 2. This corresponds to X1 plus X2 all over 2. Then Y1 plus Y2 all over 2. I mean, what exactly is that, right? You may be wondering. So, this is the fact here. Zm is Z1 plus Z2 all over 2 for the midpoint. Because we know that Z1 is X plus X1 plus IY1, then plus X2 plus IY2 all over 2. And that is equal to, if you put it all together, you have X1 plus IY1 plus X2 plus IY2 all over 2. As usual, we like to collect. Oh, no. What am I doing here? Should it be added up to like this? Okay, yeah, we get the gist, right? So in this case, now we collect like terms. That's x1 plus x2 plus I into y1 plus y2 all over 2. And then we split it up. So we have x1 plus x2 all over 2. Okay, comma, uh, y1 plus y2 all over 2. So that gives us the midpoint. That's the idea of the midpoint in this case. So in example 3 now, for example 3, we want to find the midpoint. Example 3, we want to find the midpoint of Z1 equals 2 plus 6i, Z2 equals 4 plus 2i. The solution, 2 plus 6i plus 4 plus 2i all over 2. 2 plus 4 is 6. 6 plus 2 is 8. So for the I part, so we then have 6 over 2, 3. 8 over 2, that's 4. So the answer is 3 plus 4i. So the midpoint is 3 plus 4i, like that. So, so here, if we use J, that's what we have there. So example 4 now, we want to find the midpoint of Z1 is minus 3 plus I, Z2 is 5 minus 7i. So minus 3 plus 5, that will be 2. Then 1 minus 7, that's minus 6. So 2 over 2, 1, minus 6 over 2, 3. So the answer is 1 minus 3i. Now for the combined idea now, if Z1 is 0 and Z2 is 4 plus 4i, the midpoint Zm is 4 plus 5 over 2, that is 2 plus 2i. So the absolute value of Zm minus Zi is, so Zm, that's 2 plus 2i, minus Z1, that's 0, so 2 plus 2i. Then absolute value is square root of 8. Then Z2 minus Zm, that's 2 plus 2i minus 0 also, Z2, that's 4 plus 4i minus 2 plus 2i. That's 4 minus 2, 4 minus 2. That's 2 plus 2i. That's square root of it. Both distances are equal. So we can say the midpoint divides the segment equally. So that's the essence of what a midpoint should be doing, right? So, and that's exactly the kind of idea we have here. So midpoint means that the distance. So if this is a midpoint, that is, so if this is a midpoint, right? It means that the distance from here to here is the same thing as the distance from here to here, right? So This and this are the same. That's what the concept of midpoint is about. So in summary, we see that the distance from Z1 to Z2 expanded. So if you, just like what I did before, so that's square root of x1 minus x2 all squared plus y1 minus y2 all squared. And the midpoint is z1 plus z2 all over 2, like that. So, and then we have some practice problems. As usual, I'm going to do two of them. So we have um, practice problems, find the distance. We have all of this, right? 1 to 10, then 11 to 20. So I'm going to answer two of them as usual. Um, Let me see. Yes, I'll be answering questions. Questions 3 and 19. Will that be what? Yeah. Okay. Is it 3 and 19? No. Let me see. 19. If Z1, Z2 is 10. Okay. Okay, I think it's 4 and 19. 4 and 19. Yeah. Question 4 says find the distance between Z1 is minus 2 minus 3i and Z2 is 4 plus I. Then 19 is if the absolute value of Z1 minus Z2 is equal to 10 and the midpoint is 3 plus 5. Find the possible values of Z1 and Z2. Okay, let's start with problem 4, right? Here, practice problem 4 and 19. So we'll go to the worksheet to get all of that done. So question 4, right? Problem 4. So to find the distance between Z1, which is equal to minus 2 minus 3i, and Z2, which is 4 plus I, right? So step 1, so we have step 1, we subtract, right? Step 1, subtract, because we need Z1 minus Z2, that is minus 2 minus 3i minus 4 plus I. Okay, that means we have minus 2 minus 3i minus 4 minus I. That is minus 2 minus 4 for the real part, minus I into 3 minus 1 for the imaginary part. No, that'll be 3 plus 1, yeah, because minus is out here already. So this is equal to minus 6 minus 4 minus I4, if you like, 4i. So that's step 1. So step 2. So in step 2, we take modulus. Step 2, take modulus. Take the modulus in step 2. So that's absolute value of Z1 minus Z2. That is equal to absolute value. Z1 minus Z2 is already minus 6 minus 4i. So the absolute value will just be square root of minus 6 all squared plus minus 4 all squared. That'll be square root of 36 plus 16. And that'll be square root of 52. And 52 is 4 times 13. That's square root of 4 times 13. Square root of 4 is 2. Square root of 13 is a third. So we leave it like that. Interestingly, I finished a playlist on surd recently. So that'll be 2 root 13. That's the answer to that. So that's question 4 answered. Okay, we go to problem 19 now. Problem 19. So again, I think I want to refer to it once more. Problem 19 says find the midpoint of, sorry, problem 19. Okay, if the absolute value of Z1 minus Z2 is 10 and midpoint is 3 plus 4i, find the possible values of Z1 and Z2. Okay, I think that's a bit more demanding, but let's see how we can work around that. Okay, so see, what are we given? We are given the midpoint. The midpoint is 3 plus 4i. We have that. Then we have the distance also given, We have the distance, absolute value of Z1 minus Z2 to be equal to 10. So, in this case now, if we down then let's if we let Z1 to be equal to 3 plus 4i plus x plus yi, automatically Z2 also will be equal to 3 plus 4i, being the midpoint, plus okay, minus now. So plus for one, minus for the other, minus x plus yi. Okay. So we let Z1 to be 3 plus 4i plus x plus yi, and Z2 is 3 plus 4i minus x plus yi. That makes sense because this is actually the midpoint between the two of them, right? So it's like mm, so you have a line. Let's say this is Z1 and this is Z2 and this is midpoint. The midpoint ZM is 3 plus 4i. Okay, so we are saying that Z1 now is actually 3 plus 4i. So let's say before to get to Z1, we already have the origin somewhere. So this is like x plus iy. So it means that we take Z1 to be x plus iy plus 3 plus 4i. I think this is not making solid sense, but let me see. Zm, right? So we have 3, Z1 is 3 plus 4i plus x plus yi, whereas Z2 now is this is Z2. Z2 now is 3 plus 4i minus x plus yi. That's Z2. Okay, so if that is the case, then uh of course the midpoint is automatically 3 plus 4i. That's the argument there. So we now go for step one. So we go for the distance condition. Distance condition. So for the distance condition, right? We know that absolute value of Z1 minus Z2 is equal to absolute value of 2. This distance now is going to be absolute value of x plus yi, right? And that is equal to square root of, that'll be 2x squared plus y squared automatically, right? Because 2 is constant, so that'll be 2 root x squared plus y squared in there. So now with that distance given now, we then have this given that 2 given that the distance we have, right? Given that absolute value of Z1 minus Z2 is equal to 10, then we can then imply, this can then mean we have 2 square roots of x squared plus y squared equals 10. And for this to happen, we can divide through by 2. We have square root of x squared plus y squared equals 5. So if that is the case, we can take the square of both sides as square of x squared plus y squared, square root of x squared plus y squared, and 5 squared also. So that means we have x squared plus y squared, because power 2 cancels root 2. That is equal to 5 squared. So, and then step 2 then says in step 2, choose any value satisfying this. Choose any values satisfying this. So of course, for us to have x squared plus y squared equals 5 squared, right? It has to mean that so for x squared plus y squared to be equal to 5, right? Then we can have that x is 3 and y is 4, or y is 3 and x is 4. So that's one case we can have. And then in step 3, we can compute points. Step 3, compute points. We're looking for possible values of Z1 and Z2 or so, right? So we want to compute points. So here we now have Z, since we took Z1 to be 3 plus 4i, then okay, now with this set of points now, you know, if x is 3 and y is 4, so remember that we started with z1 being 3 plus 4i plus x plus yi, right? So that means this in this case will be z1 equals 3 plus 4i plus 3 plus 4i. Now that you have found x and y to be 3 and 4. So that means z1 is equal to double of this. That is 6 plus 8i. That is z1 for us. Then for z2, we said z2 should be 3 plus 4i minus x plus yi. So if that is the case, it means z2 is now 3 plus 4i minus 3 plus 4i. That is simply 0. So Z2 is 0. So um so the final answer then can be this. Final answer is one possible pair that Z1 is 6 plus 8i and Z2 is equal to 0. Okay. And with that, it makes sense that the midpoint will be what it is now. So you can check for midpoint if this is really correct. So we know Zm Z1 should be Z1 plus Z2 all over 2. So that means that's 6 plus 8i plus 0 over 2. So that is 6 plus 8i all over 2. And that is 3 plus 4i, which is actually the midpoint actually in reality. So that works. So generally speaking, at this point, right? But when you get to this point, any value of x and y that satisfies this is okay. I mean, you could as well say, you could as well also use x is 4 and y is 3. So you can use that to get another set of values altogether. Maybe we can even try that, right? So trying trying that x is 4 and y is 3. That's also possible, right? And we know that the initial z1 is 3 plus 4i plus x plus yi. So that means we have 3 plus 4i plus 4 plus 3i, So that will give us 7 plus 7i, like that. So for z2 now, for z2, we have 3 plus 4i minus x plus yi. So that means z2 would be 3 plus 4i minus 4 plus 3i. So these ones are not the same now. So we have z2 to be 3 plus 4i minus 4 minus 3i. So that means z2 is 3 minus 4 is minus 1, 4i minus 3, that's plus I. Okay, so that's z2 in this case. So can we check to be sure it's correct? So we check Zm is equal to Z1 plus Z2 over 2. So Z1 is 7 plus 7i. So we have 7 plus 7i plus Z2 minus 1 plus I. So that's minus 1 plus I all over 2. So that means we have 7 plus 7i minus 1 plus 1 all over 2. So 7 minus 1, this 7 minus 1, that's 6. 7i plus 1, that's 8i all over 2. Okay, it's making sense still. That's 3 plus 4i, which is still the midpoint. Uh, so we can conclude. So possible possible values of Z1 and Z2 are what's the first one now? The first set of Z1. So Z1, 6 plus 8i and 0, right? Z1, Z2. Okay, that is 6 plus 8i, 0, or, and of course, Z1, Z2, that is 7 plus 7i, then minus 1 plus I. Yeah, minus 1 plus I. So, and that's how that ends. So with this, we come to the end of this interesting video about about distance and midpoint in complex numbers. Don't forget to try your hands on the 20 questions again. This is 1 to 10 and this is 11 to 20. If you let me know what if there's anything else you'd like me to try out. If you have subscribed to this channel already, I thank you very much for doing that. If you have not subscribed, it is high time you subscribed. Why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privileges like being the first to see some videos or seeing some videos exclusively. All right, seeing some videos exclusively. You could also request for PDF copies of the notes I use in teaching these classes. Um, we can also hang out at your request as a member of the channel. We can hang out online or physically if you're in the same geographical location at any point in time to discuss whatever interests you on this channel, be it mathematics, data analysis, data science, machine learning, scholarships, writing books, anything at all, or even teaching maths on YouTube. Can discuss all of that. All right. Ultimately, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.